Okay, Algebra 1, we are looking at Chapter 2, Section 6, Absolute Value Inequalities. And so I'm going to look at the absolute value of, let's take absolute value of x plus 7 is less than or equal to 2. Okay, if we recall back to our absolute value, there could possibly be two answers here. So in this case, I'm going to set up two equations again. I'm going to do a letter A, which is going to be x plus 7 is less than or equal to 2. And then my letter B, this is where it's going to get a little bit different. I'm going to do x plus 7. Now, if you remember back to chapter 1 when we did this, we would change the 2 to a negative 2. Well, in this case, to change a 2 to a negative 2, we would have to multiply by negative 1. And because we multiply by a negative number, we have to flip our inequality sign. So that's the only major difference is on that second equation, now we flip that inequality sign. Now we solve them just like normal. We subtract 7 from both sides, and we get x is less than or equal to negative 5. And we also subtract 7 from both sides here, and we get x is greater than or equal to negative 9. So in this case, we could graph this if they asked for it. And so we're going to put a number line down here. Put our 0 in the middle. If we're going to go, let's see, let's go negative 5 there, and a little bit more to negative 9. Now, that says we are less than or equal to negative 5. So that's a closed circle. And I'm just going to go a little ways because these might meet in the middle. And you notice the right one is x is greater than or equal to negative 9. So again, that's a closed circle. And it is greater than. So they are going to meet in the middle. So x is less than or equal to negative 5. And x is greater than or equal to negative 9. Now, let's take a look at something that might be just a little bit more intense. And so I'm going to have 4 times the absolute value of 2x minus 5 Okay, 4 times the absolute value of 2x minus 5 plus 1 is greater than 21. Now we have to get to the absolute value, so we have to get rid of the 4 and the 1 first. That 4 is connected to that 2x minus 5. Treat those almost like parentheses. So we're going to subtract the 1 first. So that gives us 4 times the absolute value of 2x minus 5 is now greater than 20. And so now if I treat those like parentheses, that means 4 is being multiplied by that absolute value. So I'm going to divide both sides by 4. Those 4's are going to cancel. So that leaves me the absolute value of 2x minus 5. I need to make that a little bit bigger so it doesn't look like a 12. Is greater than 5. So at this point, we are going to set up our two equations. 2x minus 5 is greater than 5. And then our second equation, 2x minus 5, remember to flip the sign because now that's a negative 5. I had to multiply it by negative 1. So we add 5 to both sides here. And we get 2x is greater than 10. Divide both sides by 2. And x is greater than 5. Add 5 to both sides. That gives me 2x is less than 0. Divide by 2. That gives me x is less than 0. So now if I'm going to graph this one, I've got 0, I've got 5. It is greater than 5, but less than 0. Now, let's look at some special instances. If I put this out in front of you, let's see. If I wanted to go, not sure which one I want to do first. Well, let's go with greater than or equal to -2. Okay. I don't want to call this a trick question. This is just a recognition question. Absolute value has to be positive. So whatever value is in here, if it's positive, it is always greater than -2 because it can't be negative. So in this case, it doesn't matter what number I put in here. If my absolute value is greater than a negative number, then all real numbers will work. Remember that the abbreviation for all real numbers is a double stem R. Every absolute value is greater than -2. And so now I look on the other hand, and let's say I had 2x plus 6 is less than or equal to -2. Could have just been less than. I just threw the equal to on there anyways. So what's less than -2? Well, -3, -4, -5, and so on and so on. And if every absolute value is positive, then none of them will ever be less than -2. So in this case, this would be a no solution. So be very careful when you see numbers that are greater than or less than negatives, because they may have actual special solutions, and it can save you a whole lot of time because you won't have to do the two equations. So that is chapter 2, section 6, absolute value inequalities.